Hello, and welcome to Teacherless. This YouTube channel, we're just going to be solving problems from the comments, and also from my classmates. And they're kind of idiots, but it's all good. I love them. So today we're going to be finding chemical equations, balancing them, and producing the Ionic equation. And if you couldn't tell from the very long title. So, from a packet that I cannot name, aluminum chloride solution reacts with silver nitrate solution to create, and that's what we're going to be solving. So, what exactly can we write from this word problem that we have here? Well, we know that aluminum and silver are both elements. And we know that, or hopefully we do know, that chloride and nitrate are two polyatomic ions. So, aluminum is positively charged with 3, and silver is positively charged with 1. Now, what are chloride and nitrate? As I just said, they're polyatomic ions. And sadly, I can't tell you any way to memorize them. There's no periodic table for polyatomic ions. You just kind of have to know what they are. There's a couple of charts you can find on just Google or YouTube. So it'd be good to memorize those. So chloride is very similar to the element chlorine. It has a -1 charge. And nitrate is NO3 with a -1 charge. Now, if you look at our version of aluminum chloride, we kind of have an issue here, which is that aluminum has a charge of +3, and chloride has a charge of -1. Now, our aluminum chloride is way too positive, and that's not good. You gotta be neutral. You do not want to be positive, nor do you want to be negative. You want to be neutral. So, in order to neutralize our compound, essentially, we need to write the number of charge for that element on each side. And that was a terrific way of explaining that. Sorry about that. But chloride has a charge of -1, right? So we don't have to write 1 for aluminum because there's clearly a 1 already, because it's right there, right? Now aluminum, on the other hand, has a positive charge of 3, so we'd have to write 3 chlorides. Now, if you look at our new form of aluminum chloride, it has a positive charge of 3 and a negative charge of 3, which equals 0, so that's perfect. Now we can do this with silver nitrate too, and silver has a charge of +1, and nitrate has a charge of -1. So those just cancel out already, we don't have to do anything about it. Now, we gotta write the products. So, normally in a double replacement, such as this equation that we have, and the way to know that it's double replacement is that it's 2 different compounds. So, normally, and when I mean normally, I mean almost 99% of the time, the 2 positives are just going to switch. So, when we write that out, on this side, we have aluminum chloride plus silver nitrate equaling to silver chloride and aluminum nitrate. But we have an issue here, which is that this is not balanced, right? Because silver has a charge of +1. And these chlorides here have a charge of -3. So this here would be negative, and aluminum has a charge of +3, and the nitrates have a charge of -1, which would make it too positive. So in order to balance it, hopefully you guys do know how to balance. You just have to write out the elements on each side, and then eventually just keep multiplying it by a certain number that could solve for the number that we require. And I'm hoping you do know how to balance equations, because that is quite an important part of chemistry. And yeah, so this is the balanced equation here. Yeah. Alright, so net ionic equations. So, in order to write the net ionic equation, we need to first write the total ionic equation. Now, the total ionic equation is just to separate every single thing, like polyatomic ion and element, and then write out the charges. So far, we're pretty good here, except for this nitrate here, which should be 3. So sorry about that. But if we were to actually read it out, it would be 3 silvers, positive 3, 3 nitrates, negative 3, 1 aluminum, which is positive 3, and 3 chlorides, which is negative 3. And that works out pretty well. So, now we have to look at the solubility rules. And the solubility rules are quite complex. I would suggest you try to memorize them, or at least try to memorize a couple of them. Now, the solubility rules are related to aqueous solutions and solid solutions, as in aqueous means that they dissolve in water, right? So that would mean that they are soluble. However, this solid here is not soluble. So most nitrates are soluble, which is why this here is an aqueous solution. And most chlorides are also soluble, which is also why it's an aqueous solution. So this nitrate here is also aqueous. However, silver causes this equation, or this compound here to be solid, which is why it's not going to dissolve. And we're going to need to know this, because if the solution, for example, dissolves in water, then we can think about something like salt. When salt dissolves in water, the sodium and the chloride, or chlorine, I believe. No, it is chloride. I was right the first time. They separate, and they become spectator ions. And similarly here, aluminum and nitrate are going to separate, which means that they're not going to be necessary. So they dissolve, and we can cancel them out, leaving us the silver and the chloride. And that means that in order to balance this equation, we have to remove the nitrate and remove the aluminum, which leaves us the silver and the chloride. So if we write that out in a better way, we get 3 silver and 3 chloride, which is equal to 3 silver chloride. And that has a charge of 0 right here. There's a solid, an aqueous, and a solid. And this is already 0, you don't have to write that out. And yay, we're good. So please subscribe. That took quite a while. My hope is that I'll try to make some videos on comments. So if you have any questions, please write in the comments. I'll be happy to solve them. And good night.